Hi there, and welcome back for part 5 of our little tutorial series about creating the classic game Pong in Unity. Today is going to be all about visual effects. And if you're just joining this series, you are free to do so. You can watch this part on its own, but if you're a beginner just starting out with game development, I highly recommend starting at part 1 of the series. But also, if you're just joining now, there's a link to the GitHub repository in the description, and you can check out the state that the repository was in right after the last tutorial. So, visual effects, or VFX in short. Why do we need them? Why do we want them? Well, besides audio and other factors, they tremendously impact the game feel, which is also often referred to as the juice of our game. They can also really enhance the visual appeal of the game and pretty much single-handedly decide the whole visual style for our game if we wanted to. That is why we'll be playing around with them a bit today and adding some of them to the game. And we have our handy to-do list ready for us. And this is what we're going to do today. First, we're going to add a little trail to the ball. Then we're going to add some collision particles that always get emitted when the ball hits a wall or a paddle. Then we're going to make a little starry background. And then one thing that is really often used in games is a camera shake, so the camera moving a bit when we hit a collision or something like that. And we'll also have a quick look at some post-processing options. Let's start with the trail for the ball. For this, we're gonna go into our level and into our ball and create a new empty child for the ball. Call this one trail. And Unity provides a component for us that makes things easier. This is called the trail renderer, and we're gonna add this component. It is actually quite similar to the line renderer that we used for the dotted line in the middle, if you remember. And now we got this trail renderer on here, and if we now move the ball, you can see this pink trail coming out of it. But we don't really want this to stay pink. We want to set our own color for it, which we can't do right now because it has no material yet. If you remember the dotted line, this is very similar. We need a material so we can set a color for this. And so let's create a new material and call it ball trail. And I encourage you to try out a few different shaders for this and see how they affect the ball trail. For me, I'm just gonna choose the one that I think works best for trails, and this is the Mobile Particles Additive shader. So now if we go to the trail and assign this one, and we move the ball again, we see it's now a white trail, and we can also adjust this color. So this one works. But of course we don't want the trail to be like this. This stays for way too long and is way too wide, and maybe we're also going to do a little fade at the end. So let's center the ball again and let's try adjusting some of these values. We can do this right here outside of play mode and then move the ball, or we can also just move the trail object to test it. This is alright, we can do this, but don't forget to center it again if you change this one. But we can also do these changes live in play mode. And I'm just gonna show you this real quick. Okay, this good old Unity exception again, let's clear it. And by the way, I pressed this mute audio button so that we don't hear the music from the last tutorial over and over again, because it would get annoying, I think. So if we start the game, we now see this trail, and yeah, maybe we can adjust its time so it doesn't stay for too long. This seems like a good length, and then we don't want it to be so wide. So let's move this one down. And now we have to restart the game every now and then to see the ball in action again. So we have this, and right here at the end, if we right click and choose add key, we can add another key at the end of the width. And for example, just to exaggerate this, if we make this wider, yeah, this This could be like a shooting star or something, but I think for our ball trail we're gonna go down to 0. Let's see how that looks. Yeah, that looks pretty cool. And let's lastly adjust the color. And I think we're gonna just leave it at white because our game is just black and white at the moment. So let's stay that way. And you see these little arrows for this gradient. Down here you can adjust the color, and up here you can adjust the alpha. And if we now set the alpha at the end to 0, we should have a little fade out at the end. Yes, you can see this. And now the important thing, if you go out of play mode now, all these changes will revert. And so, but there is a trick to save them, and you can just click. I also got a tutorial on this, by the way, which should pop up right now. So check this out if you're interested. You can click in the component, these little dots on the trailer and raw component, and choose copy component. Now, if we go out of play mode, you see these changes have reset, but we can just go in here and choose paste component values, and there they are again. And if we enter play mode again, then these changes will be there. So we now got our trail pretty much done. So let's tick it off the list already. Next up are the collision particles, and for this let's create a child of the ball again and call this one collision particle. And let's add the component, type in just particle and particle system. And okay, so now we see something. This is also pink. I think in some different Unity versions it already gets a material, a standard material assigned right away. So let's fix this right away. For you this might not be pink, but if it is pink, go down here to renderer, to material, and just type in particle again and select the default particle. So as far as I remember it, in earlier Unity versions this was assigned automatically. So it could already be like this for you, but if it's pink for you, you know what to do. Of course, you could also create your own material and assign it here so that you can customize the look of your particle to your desires. And speaking of which, customizing particles, you can do a lot with these. Like there are a ton of modules. You can adjust the speed and the size, and you can add some noise, and there are tons of options, and in combination this becomes one of the most powerful tools in your VFX toolbelt and in your visual toolbelt in general. So we are only gonna scratch the surface in this video and adjust a few parameters to our needs, but I highly encourage you to go deeper on this topic and maybe check out some more videos on YouTube. There are some great in-depth videos. I'm just gonna link one from Bracky's right here. So let's adjust some values for our particle system, and first of all, so we can see it better in the game view, I'm just going to turn this canvas off. And now on the collision particle, I still got this noise one ticked on. We're not going to use that here. So let's go through. Looping means that it just continues looping, and we don't really want that because we want bursts, but we can leave this on because we're not gonna use constant emission anyway. And for now it is helpful for us to see how our changes can be visualized. So what are we gonna do? We're gonna adjust the lifetime, like they live way too long. And this is also one more very powerful tool for the particle system. You got this little drop down on a lot of values right here, and you can choose between constant, curve, and random values. And this is so powerful. You can just randomize a lot of stuff. So let's randomize the lifetime maybe to something from 0.25 to half a second. And yeah, you can also always get tooltips for what a certain value does. So the start speed, maybe let's randomize this one too. Let's choose 1/2 between 1. So now we got like the size that we gotta adjust it. That is way too high. So let's also make this maybe the same as up here. So you can totally play around with these values. Okay, this is going in a good direction, I think. But these particles, they are like, they should emit from the ball directly. And for this, we're going to go into the shape module. And right, we gotta just decrease the radius of this. So let's maybe set this to 0.1 or maybe 0.2. Yeah, this looks subtle enough. So I want this to be a rather subtle effect. But it looks awkward right now. We can also zoom in on this one. It looks a bit awkward right now how they just disappear. And for this, we got a cool little module right down here that is called size over lifetime. And we can tick this on. And now it's growing, but we want it to be the other way around. So let's choose this curve right here. And now they're going away. Maybe I have to adjust the speed up a bit. So let's make this between 1 and 2. Yeah, this looks better, I think. I think we're gonna see this in game. But we're not gonna do this right now. So we're just gonna turn off the emission for now. And what we want, and you can, no, we're not gonna turn off the emission. We're gonna set this value rate over time. This is the constant emission value to 0. And you see it's not emitting anymore. But what we want is bursts. And if we click restart, it's gonna do this burst. And you see this? This is visualizing how we want it to be. Like if we hit a wall, bam. If we hit a pedal, bam. And maybe a little bit less than this, maybe 10 is enough, like this. Okay, but you see in a second that we can also do this burst. We don't even need this emission module. We can do this very easily in code, and this is what we're going to do next. Let's head to our ball script for the implementation, and we definitely need a reference to the particle system for this to do anything with it. And then we're going to create a new method, and I'm just a private void, and I'm just going to call this emit particle. And we're going to give it a parameter, the amount of particles that we want to emit. And then we can call it from different places in the code. And now we are just going with our collision particle and call the method emit. And we're going to give it the amount. This is pretty much exactly what the burst does. So we're doing a burst with this specific amount. Now we got to call this method somewhere, and definitely we're going to call it in onCollision enter. So when we collide with a wall, for example, we can call emit particle, and let's say let's emit 8 particles. We're going to check out how this looks in a second. And also if we collide with a pedal, maybe we can do some more. So let's go with 16, and to make maybe the initial push more exciting, let's emit particles here too, and let's go with a gigantic amount. So yeah, we got our calls all set up. Back inside Unity, we just have to assign this particle reference, and let's not forget to enable our canvas again. And now we can test this. So let's give it a whirl. And I'm gonna start the game. Oh, do you see that? Yeah, the particle, there is one problem. The particle is moving with the ball, but we want it to stay in place. This is a very easy adjustment. It's just go to the particle system, and in simulation space, instead of local, choose world. And now, if we go in again, it should stay in place and not move with the ball. So let's check this out. Yes. Okay, we got this starting particle. Yeah, I think this looks cool. Yeah, maybe a little bit less would be sufficient too, but I think this is very much fine. Feel free to adjust this to your desires and needs and however you want it. Yeah, you can do so much with this. So yeah, I think we got this collision particle all done. Just one really quick bonus information on this part. So you saw maybe this shape right here, and it says cone. but this looks more like a circle now, doesn't it? We could also just take circle here, and this is gonna change the size a lot, like it's a lot smaller in here. You gotta play around with this, but I just wanted to show you why this is a cone. And now prepare for your mind to be opened. So you got this little 2D thing right here, this little toggle, and if we press this, we are going into 3D view. And actually our whole game is just on a plane in 3D view. And this cone right here, it's actually a 3D thing, our particle emission. So if we turn on the particle emission again, and maybe, yeah, let's not give it a burst, let's give it an emission over time, and restart this, we see that it's actually emitting to the back of the screen. But for our use case, it looks fine and it works. You can feel free to adjust this to work as a circle, which is just flat. So this one would work too. Yeah, so like I said a couple of times, play around with this, explore, and be curious. Next up, let's make a starry background, and this is something we could just do with a sprite. Just make a starry background in, for example, GIMP, and put it in there. But using a particle system, we can make even this decorative element much more dynamic. So let's get to it and create this. And we can also, instead of creating an empty and then adding the component to it, go to create effects and create a particle system right away. And let's call this one stars. Let's adjust these particle system values so it looks like stars. First of all, let's disable the canvas again so we can see this better. And we don't want our stars to move, so let's set the speed to 0. And in the shape module, we want this to span the whole field of view. And for this, we are going to go with a box. And now we got to adjust the size of this box to span the whole field. So 20, yeah, this is over the whole size. And on the Y, let's go with 10. Yeah, this is good enough. So now we got these particles everywhere. And I think we want a lot more. So let's go with 100. Okay, yeah, this looks good. We're gonna adjust the size in a moment. So what else can we do? We can again use size over lifetime. And by the way, if you don't see this down here when you click the curve, and also by the way, my picture is right here. So let's dock this somewhere else. And yeah, if you don't see this, just click on here or down. Maybe it's down like this down here, and if you click on here, nothing happens. You have to click down here and it's gonna expand. So let's make a nice little curve for these, and yeah, let's adjust this value back here, and we can move these handles around so that we can get a nice little curve, and maybe like this. Yeah, this looks all right. Let's dock it back up here, just to the side. So now we got these stars. So this is a little animation for the stars that I thought of. They could just be static, but we want something dynamic. So it's more pleasant to look at. But right now this is moving way too fast. And so we're gonna adjust the starting lifetime. And let's make this a random value again between two constants, and let's set it between 10 and maybe 30. So some stars are there for longer and some are shorter lived. And now these are way too big, right? We couldn't play the game like this. So let's decrease the size by a lot. And again, one of my favorite things, the random between two constants. And let's go for 0, 0, to 5 to 0, 0, 5. And now you can barely see it in this minimized view, but if we go up here and go to maximize, then we can see the stars in the background. And I think they look quite decent. They don't distract too much from the playing field. And they also have these really subtle animations that are super subtle and don't distract, but I think they add a lot of life to the background. And yeah, I think this is already good. So let's tick this starry background off our list. Next up is screenshake or camera shake, and this is one of the most prominent and effective effects in game development. And it pretty much boils down to just randomizing the camera position a little bit over a short time. So maybe I can try to visualize this like this. Like camera shake is if we go for a second like this. Not really for a second, but even less than that. And yeah, this is a great effect to use when something crashes into something else, which is exactly what we're going to use it for, or just for some major event happening, or maybe you have a particle that has a burst and then you also enhance this effect with a little screen shake. Let's start implementing it by creating a new script and call this one shake. Notice that we're not gonna call it cam shake or screen shake, but we're gonna keep it more generic, more on that later, and assign this one to our main camera. Let's open up the script, and first of all, let's get rid of these. And the first thing we want to do is store the initial position of our camera. And this is its transform local position. Let me explain this real quick. So back inside Unity, if we have the camera and we don't store its local position, so we want the screen shake to go over a certain duration, like say 1 second. We shake for 1 second, but after half a second, when our camera is here, a new shake begins, and the camera doesn't know its original position. If it doesn't know that, it's gonna start this new shake from here, and maybe this next shake from here, and then someday we are way off the playing field. So we want to always be centered at this initial position. We could just hard code this, but with this code right here, we can just save it in a variable and have it available to us. Let me quickly explain one more thing before we move on with implementation. So you see we got this local position right here. There's also position, which is the world position. And this is an important distinction. Let me demonstrate this. So the local position is what you can see right here in the inspector. And yeah, this is 0, 0, 0 for the level, and also 0, 0, 0 for the ball. And right now, both of these also have a world position of 0, 0, 0. But what if we moved this level 1 on the x-axis? Now the level has a world and local position of 1 on the x-axis, but the ball, it still has a local position of 0 on the x-axis, but a world position of 1 because its parent has changed. So the local position is just what's here, and the world position is what's here plus everything that comes from the parents. Why is this important, you ask? Well, it's not in our case because we have a static camera, but for example, if you have a platforming game or anything else where the camera follows the player, you got these two clashing things. You got the camera follow that changes the position of the camera, and you also have this screen shake that changes the position of the camera. And in this case, you want to change for the screen shake only the local position of the camera and make it a child. I'm just going to demonstrate this real quick. So this will be the follower. So you have a script on here that follows the player, and then you have the camera and you have the shake script on here, and you just change the local position. So at the same time, it can follow the player and make a decent screen shake. Not for our case though, so I'm gonna remove this again as we have a static camera, but just so you know for your future endeavors. Let's hop back into the implementation and implement our actual shake method. Let's call it doShake because we can't call it shake because the class is already called shake. So let's call it doShake. And this is getting a max offset, and we're just going to use the same offset for the X and Y position. You can, of course, distinguish between these. And for each one, we're going to go with a random range between the max offset, the negative max offset, and the max offset. And then we're going to change the local position to our initial position that we saved at the beginning, plus a new vector 3 composed of these values. Now we want our shake to take place over a certain duration in parallel to the rest of the gameplay. So there are multiple ways to do this, and I'm going to show you two, and we're going to go with the second one. The first one would be to use the update method and introduce some Boolean value. For example, we could call it isShaking, and always when we start the shake, we set isShaking to true, and while this one is true, we do the shake. But this is a bit problematic because we still gotta count the time for the shake. It's not the most elegant way to do this, I think. What's better, and also introduces a new concept, which is great for learning, is using a so-called coroutine. And the syntax is like this. You got this enumerator return type, and then inside the coroutine, if we take this out, it's gonna give us some red. Yeah. So we got this syntax, yield return something. And this means we're gonna wait for this long. Yield return null means we're just gonna wait for one frame. This is what we're gonna use because we want the shake to change each frame. But there are also other types of waiting. You can wait for 1 second, for example, and then do something. Or you can wait until something else is finished. There's a lot you can do with coroutines, and yeah, let's implement this one next. This here is the code that we're going to use, and I'm going to quickly walk you through it. So we pass the offset and the duration into this shake sequence, and we will count how much duration has passed already. So we're going to introduce a new variable for this. And now we got this while statement. This is a loop. It means while this condition is true, we're just going to go into this body again and again and again. And once it is false, so once duration passed is not smaller than the duration we have given, then we're going to go out of it and continue after that. So what do? We check if the duration that has passed is smaller than the duration. So yeah, we're not at the end of our shake yet. While we're doing this, we do the shake with our given offset, and we add time.delta time to the duration passed. Time.delta time is the time that has passed since the last frame. Yeah, and then we got this yield return null, so we're gonna wait 1 frame for the next one. And then we're gonna go into this again and again and again. And until the duration has passed. And in the end, we don't want our camera after the shake to be in an offset position, but we're gonna reset this one to its initial position. So now all that's left for us to do in this class is to make it possible to start this shake from the outside. And we're gonna add 2 new methods for this. And the first one, public methods, is the start shake method. And it gets past the offset and the duration. So if we hit a wall, we can give a different offset or duration than if we hit a paddle, for example, if we call this from another script. And in this one, we're first gonna call the stop shake method. So what's up with this? It's possible that if we start a new shake, that the previous shake is still running, and we gotta stop that one. And how do we do this? We call stop all coroutines. This is gonna stop this coroutine, so it's not gonna continue shaking. But it's also not gonna go into this line. So we have to reset this position here again to our initial position. And once we dealt with that, we can then start a new shake. And the syntax for this, it's not just calling a method like we used to before. We also gotta use this start coroutine so that it can run in parallel. Yeah, and that's pretty much about it. We called this method from the outside. It stops the previous shake if one is running. If it isn't running, then it doesn't matter. So this is not going to hurt us when we call it. And then we will start this shake sequence. Next up, we have to reference this somewhere from the outside. And since this might get called from different scripts, let's add a reference to our game manager. So public shake, screenshake, and let's assign this one in Unity. Now let's implement the calls to this start shake method, and for this we're going to go into our ball script and into our beloved onCollisionEnter 2D method. And right here for the wall we can call game manager instance.screenshake to get the reference to the screenshake and call the start shake method. And for the wall this should be really subtle, so I'm entering very low numbers in here. For the pedal I think this can be quite a bit more, so let's go maybe with something like this. And remember, the first one is the offset and the second one is the duration. You can also see this by hovering your mouse over any method. And yeah, maybe a little bit of a bigger shake in the on score zone reached. Maybe let's just do it like this. Yeah. Let's go back into Unity and test this, and maybe we can, I'm gonna go out of play mode again and hit this maximize on play, so it automatically maximizes the view so we can see it better. Oh, and I still got the level set to 1, so let's set this back to where it belongs and start again. And now if we start the game, yes, this pedal shake is really noticeable and the wall shake is super subtle. But that's exactly the way I want it to. And the score zone reached shake is pretty damn mighty. So I think this feels good, but you feel free to play with these values as you like. Another cool thing we could do probably to enhance the experience is to make the camera shake more intense the faster the ball hits the pedal. So we can do this with just some simple math. We're going to use the square root of the magnitude of the velocity. So the velocity is how fast the ball moves and the magnitude is the length of this vector. So this one increases when the speed of the ball increases. And we're gonna square root this so it doesn't get out of control too quickly, and also give it another factor. So yeah, I tested this before, trust me, it can get out of hand pretty quickly, and let's just see how that feels. And going into play mode, let's start the game. So first we have a rather low shake when we hit the pedals, but it's already increasing and it's only increasing more. So I'm probably not good enough to show you properly, but yeah, this is something you can do to add more drama to your game. One last note on this topic of shake. Remember how we only called this shake and not cam shake or screen shake. This is applicable for any transform. So we could potentially put this on the pedal prefab and have the pedal shake whenever the ball hits it. But in this case, like I said earlier, for the camera, we'd have to make a parent-child relationship because the pedals are also moving up and down, and then this shake is a different kind of movement. So what you would do is probably make a child and only put the sprite renderer and the shake component on this child, and then shake only the sprite renderer. This also saves you from another nightmare, because if we shake the rigid body and the box collider, very weird things with the physics can happen. Like the ball hits the pedal, just imagine that, and the pedal shakes and suddenly it pushes the ball way out of space. Like stuff like that can happen. So Always be careful when using this shake stuff. There are a lot of pitfalls, and I hope I covered most of them, but it's just so worth it. So we got the screen shake all done and can tick it off the list, and all that's left to do today is post-processing, which is, again, a fascinating field. I'm just gonna take a quick break now, so don't be surprised if the lighting situation changes. See you in a second. So what is post-processing? Our camera looks into the scene, and depending on its settings, like its position or its orthographic size, it sees a different part of the scene. And what it can see, the camera, this is what it converts into an image for us to see, which is also called rendering the image. And it does this every frame. And yeah, then as a result, we get this image. And with post-processing now, we can do adjustments to this rendered image. So we don't do anything before the camera has rendered, hence post-processing, but after the camera has rendered the image, we apply some effects to it. Post-processing is therefore also called image effects or full screen effects. And the way to set this up in Unity is to go to Window, Package Manager, and it opened up on my other screen. I'm just gonna drag it over. And now it's gonna fetch packages from the Unity registry. By the way, this package manager contains a lot of cool stuff, like for example, a Cinemachine that allows you to make some very easy camera stuff and camera follow stuff. And there's also a different input system, but this is all way beyond the scope of what we are dealing with right now. We just want to have a look at post-processing. And then we can install this package, and it's gonna take a second. And yeah, once it is installed, you see this little green arrow right next to it. And in the package manager, we can see which packages we got installed in our project. Like we got all these 2D ones because we are using the 2D template, for example. But back to post-processing, we can now use it. And if you're familiar with the render pipelines in Unity, this is different for the universal and the high definition render pipeline. You don't have to install this package. But if you've been following this tutorial series, then you're not using any of the other render pipelines, but the built-in one. And for this, you have to install the package for post-processing to work. So for post-processing to actually work in our scene, we need two things. First of all, we need a post-process volume to tell Unity what to post-process. And yeah, I like creating this as a child of the main camera, and add this component, just type in post, and then you have post-process volume, and we're gonna take is global here. And yeah, actually we need three things. Okay, this is the first one, and now we got our volume, it's on the default layer, and now we add to the camera a post-process layer, and we set it also to default. Unity tells us to not use everything on default, so we could go in here and add a layer which is just for post-processing, and then select this layer and change this one to the post layer. Oh, now it's mixed. So keep in mind, if you tick something here, it doesn't untick the other ones, except if you choose nothing or everything. That's the same for every layer mask. So now we got this. We can also adjust anti-aliasing if we wanted to, but yeah, let's just choose one. I think we're not gonna see much of a difference. Maybe we can check this out live later. But what we also need is a post-process profile, and we can just click the new button here and it's going to get created. We can click on it and it's in here, and then we can add our first effect. And the one I usually use to test if everything works is the vignette. And we can just, by clicking add effect, we can choose from multiple effects here. And then we have all these variables that we can adjust. We can click all, so we can adjust them all, or we can click none and just, for example, increase the intensity of our vignette. And now we can see there's a vignette coming in. So I'm just gonna show you some more examples of effects, but I again encourage you to play around with these, and this is a lot of fun to play around with. So let's check it out. Let's maybe add a grain effect, and let's change its intensity to, yeah, something higher. You can see it in the scene view, but not so well. Okay, you can see it in the game view too, but only pretty much on the white stuff. So this is a little film grain. And next up, what we can do is add a little bloom. And I'm just gonna show you real quick examples and just adjust the intensity and not much more. So bloom makes our bright stuff in the scene, well, bloom. So they get these little halos right here, and they just, it's just such a nice effect when used in moderation. So what else do we have here? So maybe let's check out chromatic aberration, and this one adds like some different colors. You can see that here on the edges of our objects, and this is a pretty interesting effect to play around with. And you can see we're already getting into the territory of making our game less playable. So we're gonna try it in a second. There's also color grading, like we have a black and white, but now with chromatic aberration also a few other colors game. But with color grading, for example, we can very easily add some colors to our game. For example, we can use this lift here and just lift up the red, and suddenly it becomes more red or purple or blue. And this is pretty great for giving our game a certain style. One more that is pretty extreme I want to show you is the lens distortion. And yeah, let's try setting its intensity to, okay, yeah, so this distorts the lens, and maybe we can do it more like inwards. I think this looks pretty cool. Let's give it a try playing it in this state and see if we can still manage to play it. So this now is a very different experience from before. It is still barely playable, but like especially this lens distortion makes things so much different. But this is totally a style that you could use for your game. One thing you might have noticed is that the UI is not affected by the post-processing. We can change that if we want to, but usually it's pretty good to leave the UI clear. But I'm just going to show you how to change it. Go to your canvas, and on the canvas component, change the render mode from overlay to camera, and just assign your camera. And now the UI gets distorted too, and now we cannot see the tutorial anymore. But also, yeah, this has its use cases. I'm going to revert to this overlay again because I think for our game this works better. So now to finish the section off, let's try honing in these post-processing effects to a bearable amount so that we can still play the game. So I'm gonna do this lens distortion just very slightly, I think. Yeah, maybe like this. And this color, this is also too much for me. I'm more of a fan of a subtle use of these effects. So let's hone it in a bit, and let's just give it a little bit of a green tint. And for the chromatic aberration, this is actually such a cool effect, right? But it's also a bit too much. So maybe like this. And I think the bloom can be quite high, so but let's just hone it in a little bit. Yes, maybe like maybe a little bit more. Yeah, this is still a bit much. So maybe like this. And the film grain is, I think, way too much. So let's turn this also down so it's a more subtle effect. And the vignette is already quite subtle. So we can check these effects. If we just tick this box, it goes on and off and we see the difference. So maybe the vignette is still a bit much. So let's do it like this. And now let's test if we can play our game. Or maybe let's test again if it now works well with the camera too. And not so much. Like the tutorials are still too distorted. So let's not do this. Let's just give it a little try. And maybe since we're at the end of this session, let's unmute the audio again so we can have the full experience now. Alright, let's start the game and try playing it. Okay, it's still way too much post-processing, so this is pretty obvious to me, but at least for my taste. So you can go with this, but for me this is way too much. But it's cool, like with the screen shake and the sounds, this game is really coming to life. By the way, I'm gonna mute the audio again. You can actually make these post-processing changes during play mode without having to save them, because this post-process profile is an asset. And it just saves independent of being in play mode or not. So let's turn down the film grain some more, let's turn down the bloom a lot more, and less chromatic aberration. Yeah, let's make the game a little bit more boring and normal again. So this is still too much green for me, so let's hone this one in. And the lens distortion, that was actually not very noticeable. So now, yeah, I think this looks a bit better. It's still like, yeah, I don't know. It's still a bit much for my taste, but you do you. And you can create like awesome styles with this by just going way overboard on one effect or on multiple effects. Like just try out to your heart's content. So that was post-processing, and that was all we wanted to cover today. I totally encourage you again to maybe come up with some more particle effects that you can use. Like for example, a particle rain when a player gets a score or wins the game. And to really try out different settings for post-processing particles and screen shake. Yeah, you can totally create your own unique style with just a few of these knobs and make your game go from boring to awesome in mere seconds. It's kind of magical. Just make sure that while doing all these fun little adjustments that your game still remains playable. This can easily get out of hand like we've seen recently. So next time we're gonna have a look at adding an AI opponent and maybe also changing the ball angle. I'm not sure yet if this is gonna be in one video or if I'm gonna spread it out across two. You will see. Anyway, thanks for tuning in again. Have a great day. See you in the next one, and bye.